So you're going to have to imagine these cross sections popping up out of the paper at you. What's kind of nice about these ones compared to the areas is, remember how I said with the areas, whether it's dy or dx, I don't really have a good explanation. You kind of just need to look at it. This one's going to come right out and tell you. If it says the cross sections are perpendicular to the x-axis, it's a dx problem. If it says perpendicular to the y-axis, it's a dy problem. So that is the one kind of nice thing is like, yeah, it's going to tell you in the problem, so you don't have to wonder. So that's kind of nice. All right, now we're only going to draw the base of the shape. You're going to have to imagine the cross section. The base of a solid is bounded by, all right, let's go ahead and graph this. Let's plug in some numbers. If you plug in 0, what are you going to get? 1. All right, so 0, 1. If you plug in 1, you would have 1 minus a fourth be 3/4, and then same thing for -1. And if you plug in 2, 2 squared is 4, 4 over 4 would be 1, 1 minus 1 is 0. So you get 2, 0, -2, 0, and it's an upside down parabola. And then it says also the x-axis and the y-axis. So this is the base of your shape. Hey, Ms. Cole, why don't you use this side over here? It actually doesn't make a difference, but if you get a choice, why wouldn't you pick the positive part? Do you know what I'm saying? Like, it's not going to make a difference, so take the positive section. So that's the base of the three-dimensional object. Now they're also going to tell you what shape is popping up out of the paper at you. So what are our cross sections for this one? All you have to do is read it. They are what? Squares. Draw yourself a square off to the side. And it says the squares are perpendicular to the x-axis. So here's what's going on. You have an infinite number of these squares perpendicular to the x-axis like this. It's like a loaf of bread with an infinite number of slices in it. And we've just taken one slice and set it aside so that we can examine it. You've got all these slices perpendicular to the x-axis. I just took one out and set it aside. So this is going to match up with the base of the shape. And it's going to be upper graph minus lower graph, exactly like we did with the areas. So the base of our square is going to be this graph minus this graph. Now the upper graph is the 1 minus 1/4 x squared. The lower graph is the x-axis, which would be 0. So you don't need to write that. It would be minus nothing. Did that explanation sit well, or is everybody still with me? The base of your shape is upper graph minus lower graph. Now we're going to set up our integral. What do you guys think for the boundaries? From where to where? Good, 0 to 2. You're using your x-axis because it's going to be a dx problem. So 0 to 2. And what goes in there is the area of your shape. So how do you get the area of a square? Yep, side times side. It would be this squared. I'm going to write it twice because we're going to have to multiply it out. But yes, it would just be that statement squared. There are some of these we'll have to type in the calculator, but this one we'll be able to do by hand. And I don't want you to lose your algebra skills or your antiderivative skills. So when we can do it by hand, I'm going to have us do that. Okay. So multiplying this together, you'd have 1 times 1 is 1. The outsides are going to give you minus 1/4 x squared. The insides are going to give you minus 1/4 x squared. So what would that be all together? Yep, good. Minus 1/2 x squared. And then the last, negatives cancel, so it'll be positive. 1/4 times 1/4 be a 16th. And then x squared times x squared would be x to the 4th. And then we can do the antiderivative. So here's the calculus. Antiderivative of 1 just be x minus, all right, what would the next part be? Good, 1/6 x cubed plus, now you would want that to be 1/5 x to the 5th, but there's a 1/16 there. So 16 times 5 be 80, 1/80th x to the 5th, such that 0 to 2, upper boundary minus lower boundary, but really you can just plug in the 2, because if you plug in 0 to all those, it would just be nothing. So this would be 2 minus 1/6 times 8 plus 1/80th times 32. 2 to the 5th would give you 32. I'm going to stop there. I'm fine with you not simplifying. I made my tests not multiple choice. They're all free response, so you can just leave it. They don't give units for problems like these, but say there were units. It would be units, it's volumes, cube. But it's easy to forget. That's why I brought it up. It's easy to forget because you can't see the shape. Remember how I said you have to have an imagination? But imagine it. Go ahead. Yes, exactly. Yeah. And again, you have to imagine, pretend it's like a loaf of bread with an infinite number of slices like popping up towards you. And we just took like one slice out of the loaf of bread and set it aside. Pretend it's like a loaf of bread that you burned on the bottom. Like the bottom of the slice of bread is like the part I highlighted. Like that's the highlighted part. That would match up with this, like the bottom of the pan. Or I don't know, does that help? Come up with an analogy because you can't see it. You have to imagine it. All right, let's, oh, go ahead. Right, because what you're doing is your integral is adding up like all those slices, and it's an infinite number of slices from 0 to 2. So once you have all of those, it constitutes, again, it's like a 3D printer where they do a slice at a time, and then when you combine all the slices, you get a 3-dimensional shape. It's cool, right? It's so cool. Neat. All right, let's try the next one. The base of a solid is the region bounded by one arch of y equals sine of x. Okay, I'm sorry, you're gonna have to fix the labels on the x-axis. Label them by pi over 2. Please, I'm sorry about that. And we were just talking about graphing sine and cosine in the homework. Where is sine gonna start? The origin, good. So that'll start at 0, 0, and then it will wave. If you remember where it starts, then you're usually okay. Because once you get that starting point, then it's just gonna wave. So we want one arch of this graph and the x-axis. Again, like this area would be the same as this area, but take the positive one. So cross sections, they're going to tell you what the shape is, and they're going to tell you perpendicular to which axis. They are equilateral triangles. All right, so equilateral means what? Yep. All your sides are the same, perpendicular to the x-axis. So again, you've got an infinite number of these triangles perpendicular to the x-axis, all sliced up like this. We're just going to take one of them and set it aside so that we can look at it. And so the base of that shape is going to be upper graph minus lower graph. Again, just like your areas. When it's a dx problem, it's going to be upper graph minus lower graph. So what is the base of our triangle? Yeah, just sine x. Good, because it would be minus the x-axis, which is nothing. So just sine of x. So let's set up the integral. It would be from where to where? Yep, 0 to pi. Inside of there, you put the area of your shape. So how do you get an area of a triangle? Good, it's going to be 1/2. The base is sine of x. We're going to have to do a little bit of work to get the height. That's going to be a little bit of a side problem, and you're going to have to remember some geometry. Okay, so drop down the height. Now, that's going to cut this exactly in half. So from here to here is sine of x. From here to here is 1/2 sine of x. And I'm sorry, I know that's really small. I'll zoom in. So from here to here is sine of x. From here to here is 1/2 of sine of x. I'm looking at this right triangle here. What is this side going to be? Good, because it's an equilateral triangle, so all the sides are sine of x. They're all the same. So we're looking at this right triangle. It's Pythagorean theorem. It'll be h squared plus 1/2 sine of x squared equals sine of x squared. So we're going to do the Pythagorean theorem for that and solve for the height. So h squared plus, that would be 1/4 sine squared of x equals sine squared of x. And then you would subtract this over. What would that give you? Good, 3/4, because you have 1 minus 1/4, so 3/4 sine squared of x. And then square root. Now, we're not going to put plus and minus because we're talking about the height of a triangle. It's a distance, so it wouldn't be negative. Square root of 3 would just be square root of 3. Square root of 4 is 2, and then square root of sine squared, they would just cancel, and you get sine of x. Does that feel like the unit circle? It is. That's where that comes from. So this is your height. So let me zoom back out. We're going to put that in for the height. And you could use a calculator for this one. I would let you use a calculator for this. We're not going to integrate this by hand. But what did you have a question, comment? I'm interested what you're like where they actually came from. Oh, it's Pythagorean theorem. See, because I'm not a memorizer. I'm a very poor memorizer. I would rather work this out than try to memorize because then I understand where it came from. Anyway, everybody try and go ahead and type that. You do need to be in radian mode. For the trig, it does make a difference. So just take a second and double check, hit that mode button, make sure you're in radian mode. The pi button is right below clear. It's the exponent key. You just have to hit second to get it. Okay, so 0.680. And remember, you need 3 decimal points. If you don't put that 0, like if you just put 0.68, they will not give you the point. That 0 is not necessary. I always put it because I feel like I won't see my decimal point if I don't. All right, the base of a solid is the region bounded by. All right, those are the graphs you're actually going to be able to see, like the base of the shape. So x cubed plus 1. What are some points we could plot on there? Like, where would you start? 0, 1. Good. What else? 1, 2. -1, 0. Now that looks linear, but just remember it's a cubic graph, so it should wiggle. All right, y equals 0, that just is the x-axis, and then x equals 1. So it looks kind of like a Hershey kiss. A little bit. I don't know, that's half of a Hershey kiss. That's what that makes me think of. So what shape is this one? Oh, wait, that's not. Oh, you were looking at this one. All right, so rectangle. So draw yourself a rectangle. Perpendicular to what? Y-axis. Okay, that means all your slices are going this way. And it is going to be right graph minus left graph. Again, it's just like the areas. It'll be right graph minus left graph for the base of your shape. That also means you need to go and do what with this equation? You have to get it in terms of y. It has to be x equals, you have to get x by itself, rearrange it. So we're going to subtract 1. I would just write it here in the margin. Subtract 1 and then cube root. I don't know why I've gotten in the habit of like, if I have to rearrange it, I circle it once I do that. I don't know why, but that helps me remember like what I'm supposed to use. So we're going to do right graph minus left graph. What is our right graph? 1 minus this thing. So it's going to be 1 minus cube root y minus 1. So the base of your shape, again, it'll either be upper minus lower or right minus left, just like the areas. And these ones tell you what it's perpendicular to. All right, integral. You must use y values because it's a dy problem. So look at your y-axis this time. It'll be from where to where? It is 0 to 2. The common mistake is people will put -1 to 1, but you have to, like the whole thing sideways. So use your y values, 0 to 2. And then in there, you're going to put the area of your shape. So how do you get the area of a rectangle? Base times height. This is the base, 1 minus cube root of blah, blah, blah. And then we need the height. And remember, it's going to be dy at the end. Your boundaries are y values. Everything in here is going to say y, so you better put dy at the end. You can't mix and match them. Look back through the problem. They tell you what the height is. 2 times the base. So it's going to be 2 times this. And you can feel free to put that in your calculator. We're not doing that one by hand. I know it's dy. Still type x. Your calculator will never know. It'll be our little secret. Okay? It just use that variable key. Your calculator will not know. Oh my gosh, I'm so glad you asked because T is for parametric equations and theta is for polar equations. And those are 2 other topics that we're going to do this year. And when you put it into parametric mode or polar mode, when you hit that button, it'll show up T or theta. I'm so glad you asked. We are going to cover that this year. Yeah. Yeah, don't be impatient with that. Just wait. Like, don't start hitting other buttons. It'll eventually come up. I'm guessing you got the same thing as me. When mine showed up, you were like, ah. See how it's 6.40000? I think if you work this one out by hand, it actually comes out to exactly 6.4. The calculator is never quite as accurate as if you do it by hand, but you can just put the zeros just to be safe. All right, number 4. The base of a solid is the region inside the circle. All right, here we're going to review how to do circles. It equals the radius squared. This 4 is the radius squared. So the radius is 2. Also, it's not x plus or minus anything and y plus or minus anything, so it didn't get shifted. The center would be at the origin, and then the radius is 2. So center is at the origin, go 2 in each direction, and then do your best to draw a circle. I know they usually look like a squashed tomato at best. But what was that? Does it look like a squashed tomato? It looks good. All right, so that's the base of the shape. You have to imagine these shapes coming up out of the paper at you. So what is our shape? There's a lot of vocabulary in this one. Isosceles right triangle. All right, let's unpackage that. What does isosceles mean? Two sides are the same. Right triangle means there's a right angle. So it's a 45, 45, 90 triangle. Coming with me there? Okay. The hypotenuse is the base. So when you draw it, the hypotenuse is the part on the bottom. That's the base of the shape. So isosceles means two sides are the same. It's an isosceles right triangle. So it's 45, 45, 90. And the base of it is the hypotenuse. This is called the hypotenuse. Those are called the legs. So if they said a leg was the base, it would be turned the other way. All right, is this going to be dx or dy? What does it say? Dx, perpendicular to the x-axis. So that means all of your like infinite cross sections are going this way. And so we want to do upper graph minus lower graph. Here, you know what? Let me color code this. The colors don't show up real great on here, but I'm going to try my best. All right, the blue one is the upper graph, and the pink one is the lower graph. We have to get y by itself. So I'm just going to write this in the margin over here. What would you do to start getting y by itself? All right, good. Subtract over the x squared. This will be 4 minus x squared. And then square root. When you square root, you get the plus and the minus. The positive is the top half, the negative is the bottom half. So the top of this is square root 4 minus x squared. The bottom of it is negative square root 4 minus x squared. The color showed up okay, better than not. Or, oh, let me fill in the base of the shape here. So the base of this is upper graph minus lower graph. So it's going to be square root 4 minus x squared minus negative square root of 4 minus x squared. I'm writing it all out for you, but some of you are just staring at me because you know it's going to cancel out, right? Like minus negative means plus. So you would have one of these plus another one. So together you have two of them. So this is the base of the shape, of the cross section. All right, so setting up the integral, it's dx. So look at your x-axis. It would be from where to where? Yeah, and actually this one's a circle, so you almost can't mess it up. So -2 to 2. And then inside of there, you're going to put the area of your cross section. It's a triangle, so 1/2 base times height. This is the base. And then we're going to have to go back and think about what the height is. But this one's going to be easier. We're not going to have to do Pythagorean theorem. And it's because it's an isosceles right triangle. If you drop down the height, just watch me point to this for a second. From here to here, you have 2 of those square roots. So from here to here, you would have 1 of them, and the height would be the same as that because it's an isosceles right triangle. So the height is going to just be 1 of those square roots. Believe it or not, we're actually going to do this one by hand, and it's not going to be that terrible. It'll be integral -2 to 2. These cancel, the 1/2 and the 2, those are gone. And then what happens to these? Oh, bless you. Yeah, they cancel too. It'll just be 4 minus x squared dx. So that's not, it actually ends up being a much easier problem. So that antiderivative, 4x minus 1/3 x cubed, such that -2 to 2. And then upper boundary minus lower boundary. So if you plug in 2, that would be 8 minus 8/3. And then if you plug in -2, it's going to be -8 plus 8/3. If it was multiple choice and you had to keep going, do you feel like you could fight your way through that to simplify it down? I think you could. All right, the base of a solid is the region bounded by, all right, so here we're gonna graph these. 1 minus x squared. So like, give me some points we can put on there. 0, 1. Yeah, good. It's gonna be upside down parabola. So 1, 0, negative 1, 0. I think that'll be good enough. And then x to the 4th minus 1. It's still gonna be a parabola, just to the 4th instead of squared is like a little bit narrower. It's not gonna matter for our purposes because we're looking at such small numbers here. But you'll have 0, negative 1. And then the same x-intercepts, 1, 0, negative 1, 0. So this is the base of our 3-dimensional object. All right, so what kind of shape have we got? What is our cross section? All right, semicircles. And is it going to be dx or dy? Dx. So you're like infinite loaf of bread, all these slices here perpendicular to the x-axis. We're just going to take one out and set it aside. And so the base of our semicircle is going to be upper graph minus lower graph. Again, just like the areas. So which one is the upper graph? Yeah, good. So we have 1 minus x squared minus x to the 4th minus 1. Perfect. I guess you could leave it like that. That's a lot of parentheses, though. I would distribute the negative sign and combine the like terms there. It'll be 1 minus x squared minus x to the 4th plus 1. And then 1 plus 1 is 2. So 2 minus x squared minus x to the 4th. So setting up your integral, x values for the boundaries because it's dx. So it'll be from where to where? Negative 1 to 1. Yeah, and actually, again, you would kind of dodge a bullet there. It wouldn't matter if you messed it up because it would be the same. All right, and then inside of there, you're going to put the area of your shape. So how do you do the area of a semicircle? Good. 1/2 pi r squared dx. Here is the most common mistake. People get all excited, like, oh, 1/2 pi r squared. And then they put this in there. That's not the radius, it's the diameter. So what do you have to do to that? Another half. So it's 2 minus x squared minus x to the 4th over 2. Forgetting to put that over 2 is the most common thing there. But do you guys understand why? Like that's the whole way across. And the radius would just be halfway across. I get why it happens. Just be careful. Anyway, you can put that in your calculator. We're not doing that one by hand. And when you go to do the homework, well, a lot of times for these, they'll just say set up, but don't evaluate it. So it'll just be the setup for the integral. But look at the answer choices. If they're all kinds of crazy decimals, use your calculator. That alpha y equals is like your best friend, like getting the fraction bar.